4e from the chain rule and things, and sorry, let me make my life easy. Okay, so there's the question, and you can read that, I hope. So your chain rule, you first identify U, which is essentially what is inside a bracket. Are we okay? All right. So we have x to the fourth minus 2x squared plus 3. And then I need du of that, so the derivative for x cubed minus 4x. All right. And then back over here, what I'm really saying is this is y u to the fifth power. And then when I take the derivative, the first thing I do is I take the derivative of my u function, so it's 5 u to the fourth. And the chain rule says it's the derivative of kind of the big function multiplied by the derivative of the interior function. So I have 4x cubed minus 4x. And then the last thing to do is basically to resubstitute u. So I have 5x to the fourth minus 2x squared plus 3 to the fourth times 4x cubed minus 4x. And we can sort of rearrange that a little bit if we want to make it look a bit nicer, but otherwise that's essentially all that we can do here.
And we wouldn't be asked to expand that and simplify it?
No. Yeah. I was saying in sort of videos I was talking about doing out lots and lots of work. They're not expecting you to spend 10 minutes to show that you can take the derivative of a complicated equation, because you've got other things that they want to test you on. So you would not have to expand that out and try and simplify it more. Now, SETI, did that help?
Yes.
Okay.
Because what I'm trying to do is multiply, actually, I don't know what I do.
All right. I mean, I would say the only kind of thing you could do is moving this kind of in front and multiplying it with 5, because there's no exponent here. So in my answer, I just rewrote it like this. And the only reason why I'm doing that is just because we have this to the with the exponent, and so kind of putting it, it's kind of like saying 5a to the fifth, or actually it's not a, but, and so the only thing I could do is multiply this and say it's 20x cubed minus 20x, and then the rest of it. But really, that step right here hasn't done a whole lot to make it any better. And so that's why leaving it here or even here is reasonable. So if your function y equals the natural log of 3x, dy dx kind of following what your formula booklet gives you, this looks like it's the answer. What the formula booklet's not giving you is what happens if this is just x. Okay? And so literally, almost, well, I can pretty much tell you all of these type questions, you have to realize that 3x is a function inside a function. So you're essentially going to be using the chain rule pretty much every time you're given a natural log and want to find the derivative. Now let me pause to let that sink in for a moment. What I've just said is,
So is that incorrect?
it is at the moment, okay? Because what I need to think about is we have u is 3x, so du is 3. Then I'm going to fill in now that we have the natural log of u. And the derivative of the log of u is 1 over u times the derivative of u. And so what this really turns out is 3 over 3x, and we just simplify that as 1 over x. So this is how it's going to be complicated, is you'll be given something inside the natural log that you have to think about the chain rule and taking the derivative and then simplifying what's left over.
So, do you have like any tips for like identifying u? Like in most of the previous work we've been doing, it's always been inside like the brackets with a power.
Yep.
Is this just everything that follows the log?
Yes, because basically if you go back to the sort of main basic function, we're saying it's the log of x is 1 over x, and so as soon as you change that, you've put a new function inside this function. And so, Morris, your comment is essentially, yes, the natural log is the big function. Anything you put inside of it is the u, the new function. You go off and think, I know u, x squared plus 1, du, 2x. So now I have y, sorry, I'm already thinking ahead, is the natural log of u. The derivative of the natural log of u, 1 over u, but we have times du, you can almost think, and so we have 1 over x squared plus 1 times 2x.
Right, so, and the only reason we've timed by the u is so we have 1 over u times du equals dy over dx.
Yeah. This is the chain rule idea, that it's the derivative of the function times, I forgot, like we have dx over here. That you're always going to have, the chain rule is take the derivative of the big function times the derivative of the inside function. And so that's why I wrote times du here. Yes,
In an
sir.
exam situation, if we don't write dx after du, do you get the question? There's a mark.
No. It's your method, and if you show that du is 2x, then the examiner understands, yes, you are following the chain rule. You left out that little detail, but when it comes down to actually the working out, then no.
Mr. Newman.
Uh-huh.
On the, if not just in relation to calculus, but what are the examiners, are the examiners looking for a specific, very specific pattern of things in each of your answers? So if you write out a full response to a sequences and series question, and you miss out on a step just in your writing, but you get the right answer, are they going to deduct your points if you show the rest of your working through is like adequate, or that you understand the process?
Yes, because what in the mark scheme, what you would see written, although the examiners get what the mark schemes like you guys can find online is about a third of what the actual examiner mark scheme is giving, because they've condensed it down. But the examiner mark scheme, basically it says, if it's implied in the work, meaning the only way you could have gotten from here to here is that you must have done that kind of thing. And so if, as you were saying, in a sequence and series question, there's a number of steps. You can sort of, you're doing things in your head, most likely, and so you're not writing down that step, but it's clear that the only way I could go from here to here was knowing that I had these two pieces.
So the mark scheme isn't completely accurate? Did you say it doesn't show every step that you have to do?
No, what the mark scheme shows is the bare minimum.
Okay.
But that bare minimum gives you the full marks. Okay? And so, yeah, how, like, the mark scheme for a question like this, I'll find one for you, or you can probably find one just as quick, and you'll see that the mark scheme may not even say that this is necessary to write down. Okay, I'm writing it down now so that I'm showing you clearly what you're thinking. Yes, we were practicing derivatives over and over, and I gave you 20 of these to do, then yes, I can look at this and I do the chain rule in my head because I know what the chain rule says. Take the derivative of the big function. Well, the big function is natural log, so I know that, times the derivative of the interior function, I know that, and so I know it's that. And this is probably what the mark scheme would show. Now, for you, still practicing, getting here, really you need to think about here first so that you don't make an error in doing this. But yeah. Mm-hmm.
If you did the working out correct but got the derivative wrong, could you still get some points? Yes.
That's part of again, depending on the problem, like how complicated it is, if it's 3 marks, the first 2 marks are showing out your work. And so if this were a 3-mark question, then again, this may be worth a mark, but in the mark scheme, what I just had written, where I had 1 over x squared plus 1 times 2x, they may say, give this step 2 marks if you don't see this step, because it's implied that I must have known this in order to do what I had written here. And so on the mark scheme, you'll see this as, they'll have like A1, M1 implied, meaning, and up here they may have M1. But if they don't see that, then they give you the 2 marks here because you must have done it. It follows that the integral of 1 over x is the log of x plus c. Okay? So yeah, I'm moving on now to thinking about how do we deal with the integrals. And this is where the substitution, integration by substitution, you have to work through and think about that. Because just like I said, your derivatives of the natural log, I can always guarantee you're going to have something, not just x, that you'll have to do the chain rule. So along with the integration, you'll never see just the integral of 1 over x. It's too easy. So what you will see is the integral of 1 over 4x plus 1. Okay? And so again, we're going back to integration by substitution. U is 4x plus 1. Du is 4 dx. Make this clear to read. And so what I see here is I don't have 4 dx. And where I would see it, if it happened, would be on top here. If that was 4 over 4x plus 1, then I'd be happy because there's 4 dx. So I have my du. But we just have 1, so I need to make this 1 dx. And I'm tired of just hearing my own voice. What do I do to make this work? How do I fix it? Yep, somebody shout out. Yeah. So 1/4. So I have 1/4. Multiply by 1/4. And when I write this, I have 1/4 times 1 over u du. We're okay with that? Okay. And so the 1/4 just stays out. The derivative of 1 over u then is the natural log of u plus c, and replace again u.
So this method is pretty similar to integration by substitution. Just here we're applying like our log rule.
Exactly. Yeah. That's basically, I've sort of given you pieces that now, even when we talk about trig the next time around, it's nothing new. It's just use the ideas that you've already practiced with a different function, a different idea.